In section 3.2, we're going to be reviewing two more methods that are used to solve systems of linear equations. So today is going to be a review of the substitution method. That'll be part A in your notes. And then part B, we'll look at some examples of using the elimination method. And then part C, I'm calling an application of systems of linear equations. And what I mean by that is we're going to start seeing how these systems of equations are used to help us solve what you might think of as real-life examples, real-life problems. For some people, that's interpreted as meaning we're going to be doing some word problems. And so I want to help you out with a few that you're going to be doing on your homework. So let's get started. The substitution method basically says this. We need to solve for one of the variables in one of the equations and then replace that variable in the other equation. Well, in my first example here, this system is tailor-made to be solved by using the substitution method, because if you notice in the second equation I already have D solved for. One of my variables is already given to me without me having to do anything to solve for it. So this makes using the substitution method very easily. Since I have D solved for in the bottom equation, I'm going to be able to replace D in the top equation in this case. So to get my answer, I'm going to replace D in the top equation with 10, and this is going to enable me to find the value of C. All right, so this is familiar territory for us. 3 times 10 is 30. Subtracting 30 from both sides. And I get the value of C, which is -6. So as an ordered pair, just like you did when you were solving using the graphing method and we showed our answer, if there was a solution, we showed it using an ordered pair. Do the same thing here, and don't be confused by variables other than x and y. I know we're always used to seeing coordinates as this is the x coordinate and this is the y coordinate. If you're given other variables besides x and y, just think alphabetically. C comes before D, so this would be the C of my ordered pair, -6, and the second number of the ordered pair would be D, which is 10. So this would be my answer as an ordered pair for this first example. Okay, let's take a look at another example. Again, substitution says pick one of the equations, solve for one of the variables in that equation, and then replace that variable in the other equation. Well, there's really 4 choices here of variables, 2 x's and 2 y's. I'm really trying to decide of these 4 choices, do I want to solve for x, for example, do I want to solve for x in the top equation? Do I want to solve for y in the top equation? X in the bottom equation, y in the bottom equation. Well, in this particular case, if you'll notice, one of my variables has a coefficient of 1. And this doesn't always happen, but when it does, it's nice. We should be targeting the variable that we should solve for should be the variable that has a coefficient of 1 or -1. Either one of those is easy. 1, of course, would be easier. It would require fewer steps to solve for a variable than -1. But in either case, they're both pretty easy. So there aren't any wrong choices here. I mean, I could get my answer by solving either for either x or either y, but there is a better choice. There is a best choice, and that is solving this bottom equation for x, because I can do that in one step. If I just add 3y to both sides, I've got it solved for x. All of the others are going to require 2 steps. I'm going to have to add And then I'm going to have to divide by whatever the coefficient is in front of the variable. So if we can save a step, it makes sense to go ahead and do that. So I'm going to start by solving the bottom equation for x. And once again, that means I'm going to add 3y to both sides of this equation. Okay, well, substitution says solve for a variable. We just did that. And then replace that variable in the other equation. So in this other equation, the top equation in this case, I'm going to replace x with 3y plus 3. Okay, I have a statement here that says x is 3y plus 3. Well, if it is, then I can replace the x in the other equation with 3y plus 3 because apparently we've discovered that they're the same. Okay, so let's do that. Negative 2 times 3y plus 3 plus 5y is negative 2. I need to do the distributive property. Negative 6y minus 6 plus 5y equals negative 2. I'm going to combine like terms. Negative 6 plus 5y is negative 1y. I'm going to bring down minus 6. I'm going to add 6 to both sides. And I still haven't solved for y. It's solved for negative y. I always want to solve for the positive. So you can either think multiply both sides of this by negative 1 or divide by negative 1. Really doesn't matter. In either case, you're going to get y is negative 4. So for my ordered pair, which I do want you to write your answer as an ordered pair, I know what the y value is. I know that y is negative 4. So how can I find x? Well, I've got choices. I can let y be replaced with negative 4 in this top equation. I can do the same thing in the bottom equation and solve for x. Or it kind of makes sense that since I already have this bottom equation solved for x, and if I'm confident that I did that correctly, then since this is already set up to find x given an input for y, let's just go ahead and use this equation. And that makes it a little simpler. So I'm going to replace y with negative 4 and find x. Negative 12 plus 3, and I found out my solution for x is negative 9. So remember, solving a system means I'm finding both x and y, and these values for x and y must make both equations true. So I'm not going to take the time to do it, but if you want confidence that you got the correct answer, let x be negative 9, y be negative 4, and when you do that for both equations, you should have true statements. Okay, let's try another one. See if you can identify which of the 4 options, which variable in which equation would be the easiest. There's really not a wrong choice, but there is a better or best choice. And hopefully you've identified this minus y in the top. That's going to be a little bit easier to deal with. And another thing is hopefully you're going to avoid having to input fractions. If you can avoid having an expression that contains fractions, that's always good. Most people do not do so well with fractions. So I'm going to choose to solve for y in this top equation. So my first step in doing that is to subtract 3x from both sides. So I've got negative y equals negative 3x. And then it's pretty easy. Positive y must equal positive 3x. Okay, so once again, I'll repeat this. Substitution says solve for one variable in one equation and then replace that variable in the other equation. So in the bottom equation, I'm going to replace y, or substitute y, with 3x. 4x plus 3 times 3x is equal to 26. multiply first. 4x plus 9x is 26. Combine like terms, 13x is 26. So half of my answer, half of my ordered pair, I've got the x value is 2. And now I just have to find out what y is, and I've got, again, choices. I could let x be replaced with 2 in this top red equation, the bottom red equation, solve for y after doing that. But it makes sense since I've already got this set up to find y given a certain input of x. Let's just use this equation. So that's pretty easy. Y equals 3 times 2. And so my y value for the ordered pair will be 6. So my final answer is x equals 2, y equals 6. Okay, well, here's my last substitution example, and then we'll move on to elimination. Let's see if there's a best way to approach this. If you notice in this top equation, by the way, obviously I don't have a coefficient of 1 or -1, so my next best option is to see if I can choose a variable that when I solve for it, I'm avoiding fractions. Again, it's not always possible to avoid fractions in the expression, but when it is, let's see if we can identify those opportunities. Well, notice, if I solve for x in this top equation, I'm going to need 2 steps. I'm going to need to add 6y, and then I'm going to have to divide everything by 3. Well, the good thing about that is all of these numbers, both of these numbers, are evenly divisible by 3. So that helps me to avoid fractions. If I solve for y, I'm going to have to subtract 3x, and then I'm going to divide by -6. Well, -6 will be divisible by -6, obviously. And over here, I'm going to have 3 divided by -6, which is -1/2. That's not terrible, but again, I'll have to input a fraction. And the same will happen here if I try to solve for x or y. So it looks like the best option, not that there, again, is a wrong option, but the best option would be to solve this top equation for x. So once again, that's going to involve adding 6y to both sides, and now dividing by 3 on both sides. And we get x equals 2y, 6y divided by 3. Remember, I'm dividing everything by 3. And the result should give me this. So again, substitution says solve for a variable. We just did that. We solved for x, and then replace that variable in the other equation. So I'm going to replace x in the bottom equation with 2y minus 2. Okay, distributive property, 8y minus 8 minus 5y is 4. Combine like terms. 8y minus 5y is 3y. Add 8 to both sides. And we got our y value. Y is 4. So now let's work on the x value of the ordered pair. And once again, I know we've talked about this, but you have choices. It really doesn't matter whether you choose the top red equation, let y become 4, solve for x. Bottom red equation, let y become 4, solve for x. This makes sense since I've got this equation, the top equation already solved for x. Let's just let y become 4 in this equation, and that'll make it pretty simple. So 2 times 4, which is 8, minus 2 is 6. So that becomes my answer for number 4. Okay, now let's leave the substitution method and let's talk about another method. This will be part B in your notes. Let's talk about elimination. The whole idea behind elimination is you've got this system of 2 linear equations. You've got like terms on top of each other. We've got x terms grouped together vertically, y terms together vertically, and then these constants together. So elimination says, just like its name, one of these variables, either x or y, needs to be canceled. You can think of the word cancel, or they need to become 0 when either added together or subtracted from each other. So this particular example is set up perfectly for the elimination method, because if you notice, these y terms are opposites, and all it will take to eliminate y, or again you could think of the word cancel y, is to add these two equations together. That's going to involve adding all of the like terms together. So I'm putting a little plus sign there as a reminder that everything, all of these like terms, are going to be added together. Some people get carried away and they add here, but then they do something else with the other parts. When you make that decision on what it takes to eliminate your variable, that operation needs to be done for every part, all of the other terms. Okay, so 3x plus 2x, of course, is 5x. Something's up with my pen here. Sorry about that. 3x plus 2x is 5x. Negative 2 plus 2, of course, is 0. And then on the right side of the equation, I have 14 plus 6, which is 20. So it's going to be pretty simple to solve for x. 20 divided by 5, which is 4. Okay, we're still writing ordered pair answers. Now at this point, I don't have any difference between the elimination method and the substitution method that we just talked about. So I'm really back to what I did before. I'm going to choose one of these equations, it doesn't matter which, and I'm going to let x be replaced with 4. So I think I'm just going to go with the bottom equation. 2 times x, which we've said is 4, plus 2y equals 6. So obviously solving this equation for y will get me the other part of my answer. All right, just multiplied 2 times 4. I'm going to subtract 8 from both sides. 6 minus 8 is negative 2. So we got the y value, which is negative 1. All right, and so that ends up being my solution. And then once again, you can check and make sure. Let's just do a quick mental check. 3 times 4 is 12. Minus negative 2, that's the same thing as 12 plus 2, that is 14. That checks out. But we also have to make the bottom equation true. So 2 times 4 is 8, plus negative 2 is 6. So we know with confidence that we got the right answer. Okay, well, let's look at another example. In this particular case, it's not quite as easy as the last one. I can't just add or subtract the given equations to make a variable eliminate or cancel. So this is one of those examples where I'm going to have to multiply one of the equations. I don't have to multiply both. I just need to multiply one of the equations by a particular number that would cause either a match, exact match between the terms, or opposites. Now you may have come from Algebra 1 where you're always trying to create opposites, so you always add. And if that's what you're used to, that's fine. You can stay with that. I'm going to leave it up to you. Here's an example of multiplying, for example, the bottom equation by 3. Don't forget, that's both sides of the equation by 3. And the result, I'm just going to rewrite the top equation of this system because I didn't have to do anything to the top equation. But the bottom equation, everything being multiplied by 3, will give me this, negative 21x plus 6y equals 93. Okay, so now I'm just going to ask myself the question, what operation, and my choices are addition or subtraction, what operation will be required to cancel my y terms? Well, they're the same, and I know that any number minus itself is always 0. So my operation here is going to be subtraction. So as a reminder, maybe I'll erase that little arrow just so you won't be confused. I think it's important once you've decided the operation. Now maybe you decided to multiply by -3 on both sides, and so that gave you positive 21x minus 6y and then minus 93. So now you're adding. And that's like the situation I told you earlier. Some Algebra 1 teachers will say, always create addition. So you continue doing that if you like. And I just like to give you options because either one of them work. You just have to be careful. Here I'm subtracting a negative number. I know that that's addition. So 10 plus 21x is 31x. Okay. 6 minus 6 is 0. And then over on the right side, I'm going to do 0 minus 93, which is negative 93. And now it's pretty simple. Divide by 31 on both sides, and we got x is negative 3. So we got half the answer. We got the x coordinate of this. If we were graphing, the point of intersection would be negative 3 something. Well, let's figure out what the y coordinate is for our answer. And again, it doesn't matter which of these equations you choose. I'm just going to go with the top one. So I'm going to input negative 3 for x and solve for y. Negative 30 plus 6y is 0. Add 30 to both sides and divide by 6 on both sides, and we got the other part of our answer, our solution. Okay, so far so good. All right, I've got one more example. Let me just back up a minute. Did not have to do anything to eliminate. That was our first example. Those are really nice. We multiplied by one equation only to force elimination. Not too bad. But here's an example of it's going to be necessary, since we have to do the elimination method, it's going to be necessary to multiply both equations. We just have to decide, do we want to eliminate m or n? And I think it doesn't really matter which one you choose. I think I'm going to eliminate m. Now this time, I think I will create opposites. Okay, so what I'm going to do to eliminate m is I'm going to multiply the top equation by negative 3. So negative 3 times 2 is negative 6m. So if I want to create the opposite term so that when I add these together I get 0, that means I'm going to multiply the bottom equation by positive 2. Because 2 times 3 is positive 6m. So I'm going to end up with negative 6m on the top, positive 6m on the bottom, and if I just add those together, then I will cancel or eliminate. So just don't forget, easy mistake or a common mistake for people to make is when you choose a number to multiply times this equation, you're multiplying by the whole equation, both sides, every term. So the result will be negative 6m minus 12n equals positive 12. Notice we did the right side as well. On the bottom, we're multiplying everything by 2. Both sides, every term, 6m plus 10n equals negative 6. And now to make these cancel, I'm going to have to use the operation addition. So here's my reminder that not only am I adding these together, but I'm adding everything else together, all the like terms. All right, m is canceled. Negative 12 plus 10 is negative 2n. And 12 plus negative 6 is positive 6. Dividing both sides by negative 2, we get n is negative 3. And now I get to pick. Doesn't really matter. I think I'll go with the bottom one this time. We used the top one, I think, the last time. Just so you'll know, it really doesn't matter which one you choose. So we're going to let n be replaced with -3 and solve for m. Okay, add 15 to both sides, and then we get our solution for m, which is 4. So my final answer as an ordered pair will be 4, -3. Okay, good deal. And so the first part of your lesson will be solving systems by the substitution method. Then the next block of problems will be the elimination method. So now part C in your notes, let's see how these systems apply in just solving some everyday, real-life type problems. Or maybe you're thinking, oh no, the dreaded word problems. Okay, so this is taken directly from your book, and I'm going to change one of the instructions that the book gives you. So let's just talk through this for a second. You're going on vacation. You've got to leave your dog in a kennel, and there's really two choices. You've got one kennel called the Bow Wowry, and they charge you $25 for each day. And that's how their charge is calculated. The other kennel called the Pooch Pad, their structure for charging is they're going to charge you $20 a day, and then they've also got this one-time fee. It doesn't really matter how many days you stay, you're going to pay this $30 whether you stay 1 day or 20 days. Okay, so let's go down to letter A. We're supposed to write a system of equations that will be cost determined for a certain number of days. Okay, so I'm just going to label my equations by the name of the kennel. So here's my Bow Wowry. What does its equation look like? Okay, well, let's think about it. We're supposed to use a C for cost, determined by, the cost is determined by a certain number of days that your pet will stay. Okay, so you can think of it this way. D is like an input. Okay, remember, we're ultimately writing a linear equation, and this is our slope-intercept form. So think about writing an equation that looks something like this, and X is our input to give us the resulting output. Well, in this case, the cost is determined by how many days. So in this case, D will stand for a number of days. It's the input, and it's that input that will determine whatever the cost is, or the output. Okay. All right, so cost, C, is determined by, for the Bow Wowry, $25 per day. I don't know if you remember, hopefully you do. In Chapter 2, we learned of a way to identify the slope of a line. Slope, another way of explaining slope, is a constant rate of change. This particular kennel, the cost, will change depending on how many days the dog stays, and that constant is 25. So this is just another way of telling you what the slope of the line is. 25, that constant rate of change, is the slope, and we've already discussed the fact that the input, the number that will determine ultimately what the charge is D, which is days. So my equation to represent the charge for the Bow Wowry, hard for me to say, cost is determined by 25 times the number of days. C equals 25D. Okay, well, let's look at the Pooch Pad. I'll just do PP. The cost for this kennel is a little different. We still have this constant rate of change. It's a little less, $20 a day. The slope is 20. The input value is D. But then we've got this one-time fee. It's not affected by the number of days. It's going to be assessed no matter how many days. So this is another way of saying a y-intercept. It's just a constant. It's not determined. The cost is not going to be determined by 30 times the number of days. It's just a flat $30. So that would be like your y-intercept. So hopefully you're getting used to seeing slope being described in this way, a certain number, and then it's a rate. In this case, it's the rate of a certain dollar amount per day, constant rate of change. So this is my system. So what I want you to do, and I've kind of got you set up, the book on letter B says to use a graphing calculator, but you're not required to have a graphing calculator for this class. So just ignore those, and I want you to use either substitution or elimination, and you're basically going to solve the system. I'll give you a strong hint. I think it's set up really well for substitution because you have these variables already solved for. So to answer the question, the number of days where the costs are the same, you're basically just going to let one of these expressions, if this is C, then replace C in the other equation. 20D plus 30 is equal to 25D. And when you solve this, you will know how many days it will take for the cost of these two kennels to be basically the same. And then hopefully you'll be able then to answer letter C. If you stayed 7 days a week, then which one would you choose? Obviously, with all other factors remaining constant, you're going to choose the one that's less. So which one of these? That's pretty easy to do. If you let D be 7, obviously which one would be the lowest charge? Okay, I'll let you finish that up. Let's take a look at another one. We'll get you started. You and your business partner are mailing flyers. Okay, so we've got you. We need to write an equation for you and how many flyers you've made, and then we'll do another separate equation for your partner. Okay, so let's see what we got. You address 6 flyers each minute. There's that phrase again. Are you recognizing that that's really another way of describing slope? The slope is 6 times 6 would be the slope, and 6 will be multiplied times a certain number of minutes, and that's constantly changing our number of flyers. You've already done 80, fixed number. Well, that's another way of saying that's my y-intercept. Okay, this is a rate of change. This isn't going to change. You've already done 80 and it's fixed. That's not changing, but this describes a rate of change in the number of flyers that are made. So you're not told to use any certain variables, so I'm just going to use y for the number of flyers. Number of flyers made is determined by this rate of change, 6 times minutes, 6 per minute, and then we already have 80 that's already made. That's like a starting number. So that's my equation for you. Now let's do the same thing for your partner. Number of flyers for your partner, how many they've made, will be determined by this rate of change, 4 per minute. That's another way of saying slope, 4 times a certain number of minutes. And he's already done, or she has already done 100, so that's your starting number. Okay, well, that's your system. And so once again, I want to, much like the other one, I think we've done the hard part. Let's see if you can let, using substitution is probably easier, but I'll let you use either one. Let this expression replace y in the top, or you could do the other way. You could let this expression replace y in the bottom. And when you solve for x, x of course stands for a number of minutes. So after how many minutes will you have both made the same number of flyers? And you're basically solving for x here. So see if you can finish that problem. Okay, so this is my last one. I want to get you set up on this one and see if you can finish it. You have signed up for a bike-a-thon, and you know how those work. You try to get sponsors. So we're told that one person, so we'll just call that one person. Let's see, one person is going to give you, they're going to donate 50 cents per mile. There it is again. A way of describing slope. My slope is 0.5 times a number of miles. So this is pretty easy. The one person, I'm told to use D for donation, and my slope is 0.5 times the number of miles. So that's the equation for the one person that says they're just going to give you 50 cents for every mile you bike. Everybody else, we'll just say all others, their donation isn't based on a certain number per mile, so there is no constant rate of change in the donation based on the number of miles biked. It's just a flat $15. Okay, whether you bike 1 mile or 30 miles or 300 miles, it really doesn't matter. They're going to give you $15, and so that makes it easy. There is no constant rate of change. It's just strictly $15, which is like saying that's your y-intercept, 0m plus 15. All right, so there's your system. And then you're back to doing what you did in the previous problems. Solve this system, and you're basically solving for m. After how many miles of biking will basically these two groups, this one person and everybody else, they'll basically be giving you the same amount of money. So easy enough. You're going to let 15, which is D, you can let 15 replace D in the top equation, and I'll let you finish it from here. You're solving for m, which is miles. Okay, well, I want to, maybe that'll help you. I've given you some other word problems that I want to see if you can do. They're much like what you've seen here in your notes. So work hard on this assignment, and just get in touch with me if you have any questions.